AP Calculus AB, Unit 8, Day 5, Office Hours. Multiple choice, non-multiple choice worksheet. So check your answers real quick. These are just the answers. You can pause the video for each page. So these are all the answers on the first page. Pause the video, check your answers. They're also online, so hopefully you check them before. Here's the next page, 9 through 14. Pause the video, check your answers. And that's it. So let's try these problems now. Let's see. So the very first problem, let's see, let's zoom in here. So multiple choice, you gotta show work. Doesn't mean don't show work. So there's probably gonna be a lot of U-substitution on these problems. So first one, we could do U equals 3x plus 4. Du equals 3 dx. Don't want the 3. So this is going to be 1/3 sine u du. And then that's going to be 1/3 cosine u, but you need an extra negative in front, plus c. And then we're going to change it back to original variables, 3x plus 4, in for the u. And then hopefully the answer's other. A lot of times multiple choice makes you work a little harder. You have to manipulate your answer to fit it. Okay, this is like velocity and position. This is initial condition. So position is, since s prime equals velocity, then s, if we want to undo it, we're going to integrate velocity, because velocity is the derivative. So we got to integrate sine 2t dt. Now we can do U substitution. I feel like this is kind of a simple case, so you can probably pull it off without going through the steps here. But you're going to need an extra 1/2 in front. So it's going to be 1/2 sine u du. That's going to be 1/2 cosine u plus c. I need an extra negative because of the cosine. Cosine is a negative sign, don't want a negative. That's going to be negative 1/2 cosine 2t plus c. So that's your position function. We want to go and find the c value. You'll notice none of these have c's, but they give you initial conditions. So if you plug 0 in, should come out to 0. Now cosine 0 is 1. So c equals positive 1/2. So the equation should be negative 1/2 cosine of 2t plus 1/2. So we find the c values in the initial condition. Negative 1/2 cosine t plus 1/2. Looks like you answered D. Okay, number 3, secant squared, tangent squared. I mean, it could be helpful to rewrite these like that. So what should be our u, secant or tangent? Now remember, whatever you pick for u, you should see the derivative of with all the other stuff. You pick secant, it's going to be secant tan, you're going to have an extra tan. If you pick tangent, then du equals secant squared. And that's going to work because you have the secant squared dx. So this is going to be u squared du. So it's going to be u cubed over 3 plus c. So that's going to be 1/3 tangent cubed plus c. 1/3 tangent cubed plus c. 1/3 tangent cubed plus c. All right, number 4. Usually the inner function is stuff that's inside other stuff. All right, at least something good to try. X dx, perfect. Don't want the 2. So that's going to be 1/2 integral of the square root of u du. I'm going to rewrite that 1/2 integral of u to the 1/2 du. It's power rule. So it's going to be 1/2 u to the 3/2 divided by the new exponent multiplied by the reciprocal plus c. Final answer needs to be rewritten back in terms of the original variable. So that's going to be x squared plus plus 1 to the 3 halves plus c. 1/3 x squared plus 1 to the 3 halves plus c. There it is, answer C. Okay, number 5. U equals the inner function x squared plus 2. Du equals 2x dx. And so we're going to have a 1/2 x dx, 1/2 u squared du. So that's going to be 1/2 u cubed over 3 plus c. Final answer, we want to rewrite in terms of the original variables. 1/6 x squared plus 2 to the third power plus c. Hope you guys are getting the hang of this. Now this one you might say, oh, is that inverse tangent? Or what? Well, let's not go there yet. Let's just try something simple. A lot of times something simple works. If you try something hard, you get stuck because it doesn't work, and then you don't know what to do because you skip the simple case. It's going to be 12x squared dx. Perfect. X squared dx. I don't want the 12. Easy fix. So it's going to be 1/12 du over the square root of u. So that's going to be 1/12 integral of u to the negative 1/2 du. So that's going to be 1/12 u to the 1/2 divided by the new exponent multiplied by the reciprocal plus c. Final answer, I want to rewrite back in terms of the original variables. 1/6 square root of x 4x cubed plus 3 plus c. There you go. All right, number 7. I'm going to go with u is probably going to be tangent 3x. Let's try that. Du equals derivative tangent is secant squared. But then you got to do chain rule times derivative of what's inside, and then a dx. Now I don't want the 3, so I'm going to divide the 3 out to the other side. So I'm going to rewrite this as 1/3 e to the u du, because secant squared 3x dx is du now. So this is now a super simple antiderivative e to the u plus c. Rewrite it back in terms of the original variables. There we go. Not bad. Number 8. This is x to the 1/2, and this is e to the x to the 3 halves. I'm tempted, I think. Let's try some different things. Don't be, I think I'm going to go with x to the 3 halves. Because then du equals 3 halves x to the 1/2 dx. And that's good. X to the half dx. I don't want the 3 halves, so I'm going to multiply both sides by 2/3. So I'm going to get a 2/3 in front. And then I'm going to get an e to the u du. So that's going to be 2/3 e to the u plus c. That's going to be 2/3 e to the square root of x cubed plus c. That worked. A few more. All right, we could try u equals 3 minus x. This is a funny one. Derivative is -1 dx. You're like, well, I don't want the negative. But when you rewrite this, you have an x still, and the square root of u, negative in front, du, and that's not going to work. You can't have x's with your u's. So one option, if nothing else works better, is that you could solve for x in terms of u. So this would be x equals 3 minus u. And you can replace that right there. Now, hopefully this works. So that's going to be 3 minus u in parentheses, and then you have u to the 1/2. And then what you could do is distribute this. So it'd be negative, you get 3u to the 1/2 minus u to the 3 halves, rules of exponents. So then when you integrate, it's going to be -3. Yeah, distribute this negative, right? Negative u to the 3 halves divided by the new exponent multiplied by the reciprocal plus u to the 5 halves divided by the new exponent multiplied by the reciprocal plus c. Final answer we want to write nicely in the original variables. So -2 parentheses 3x to the 3 halves plus 2/5, 3 minus x to the 5 halves plus c. Okay, all right, number 10. U equals 2x plus 4. Usually what's inside is your u, right? 2 dx. So we're getting that same problem here. We have a 1/2, but then we have an x squared. Like, how do we do that? Well, we could solve for x. 2x equals u minus 4 divided by 2, and then x squared would be, you could plug this in. So that would be u minus 4 over 2 all squared. And then you have a u to the 1/2 du. So you square the bottom 2, that's going to give you 4. So we have a 1/8 in front now. And we get u squared minus 8u plus 16. So then we're going to distribute this in. So we get u to the 5 halves minus 8u to the 3 halves plus 16u to the 1/2. And so the antiderivative, I mean, we have to distribute this at 1/8, so you could do it as you're doing it, but that might mess you up. U to the 7 halves, divided by the new exponent, multiplied by the reciprocal, minus 8. U to the 5 halves, divided by the new exponent, or multiplied by the reciprocal, plus 16. U to the 3 halves, divided by 3 halves, multiplied by the reciprocal, 2/3. Plus c. Now, we don't have to distribute the 1/8 to plus c, but we do need, for our final answer, change everything back into terms of x. So I'm going to do that at the same time here. So that's going to be 1 over 28, 2x plus 4 to the 7 halves. Then I got to distribute this. So that's going to be minus 2/5, 2x plus 4 to the 5 halves. And this is going to be plus 4/3, 2x plus 4 to the 3 halves, and then plus c. There you go. All right, number 11. If you do the whole denominator, u equals x natural log x, the derivative of that's going to be a mess. It's a product rule, probably not. So maybe you should just go for the natural log of x, because the derivative of natural log of x is 1 over x dx, which works really nice. So that's going to be du over u. So it's going to be natural log of the absolute value of u plus c. So it's going to be natural log of the absolute value of u, which is natural log of x. You need these absolute values around the outer natural log. Okay. Okay, next one, I think u could be tangent x. Du is secant squared x dx. So that's going to be u du. U squared over 2 plus c. 1/2 tangent squared plus c. Now, an interesting approach is, this one's kind of funny, you could have picked u to be secant. Let's try it this way. U equals secant, du equals secant tan dx. And this actually works out, because there's a secant, right? And a secant tan, if you break it up. So you could totally do it like this. So now it's going to be u du. It's going to be u squared over 2 plus c. It's going to be 1/2, but now u is secant squared x. And that's the answer. And this works if you use Pythagorean trig, then you can change one to look like the other, but totally cool that you can do it 2 different ways. 13, I'm giving you the second derivative, and I'm giving initial value of the first derivative, initial value of the original function. So that means you should be able to find the c values as you go. So we're going to integrate. So f prime of x equals the integral of f double prime of x. It's going to equal the integral of sine 2x dx. So I'm going to go with u equals 2x, du equals 2 dx. I don't want the 2. So that means we're going to get 1/2 of sine u du, which is going to be 1/2 cosine u plus c, but a negative. And then we got to change it back to the original variable. So it's going to be negative 1/2 cosine of 2x plus c. And now we're going to find the c value using the first derivative initial value. So if we plug 0 into f prime, we should get 3 out. And this is going to be a 1. So c equals 3.5. 7/2 would be better. So we're going to write it now. F prime of x equals negative 1/2 cosine of 2x plus 7/2. So we're halfway there. So to get the original function, we have to integrate f prime of x, which means we're going to integrate this. Now we could use U-substitution again, but I would just use it for this term on its own. To integrate this term on its own, separately. I'll show you what I mean. So this guy, there's already a negative 1/2. We're going to get another 1/2. And it's going to be cosine u du. I'm going to integrate this one on its own. Don't do the u stuff for that one. It doesn't need it. I mean, you could probably try and make it, but use it, but you're probably going to mess it up. So you have negative 1/4. Answer derivative of cosine is sine. This is going to be 7/2 x plus c. We got to change it back to all x variables. So u was 2x. So let's use initial condition. If you plug 0 in, you should get 1 out. And these all go away, so c equals 1. So your final answer, f of x, equals negative 1/4 sine 2x plus 7/2 x plus 1. Wow, that was a lot of work. All right, number 14, kind of the same, except I'm giving you acceleration, which is s double prime, right? And I'm giving velocity, which is s prime. So this is kind of the same kind of problem, but just a little motion mixed in. So if you want velocity, you're going to have to integrate v prime, which is the same as integrating acceleration, which is going to be the same as integrating sine 3t dt. So we could do u equals 3t, du equals 3 dt, and I don't want the 3. So velocity is going to be 1/3 the integral of sine u du, which is going to be 1/3 cosine u plus c. This is going to have a negative. So then we can use the initial condition v0, negative 1/3 cosine 0 plus c should add up to 2. Cosine 0 is 1, so c equals 2 1/3, or 7/3. So your velocity equation is now negative 1/3 cosine of 3t plus 7/3. That's not the final answer, so I don't know why I box it, but it's kind of an important step. It's the velocity. So position is going to equal the integral of s prime. And s prime is the same thing as the velocity, which we just found, which is going to be the integral from negative 1/3 cosine 3t plus 7/3 dt. Now we can do u substitution for this. U equals 3t, du equals 3 dt. I want the 3. So st equals, we already have a negative 1/3. We can get another 1/3 integral of cosine u du. Then I'd separate this guy plus the integral of 7/3 dt. So this is going to be negative 1/9 sine u plus 7/3 t plus c. Rewrite it back in terms of the original variables. So it's negative 1/9 sine of 3t plus 7/3 t plus c. Use the initial condition S0, they said it was 3, so negative 1/9 sine of 0 plus 7/3 of 0 plus c should equal 3. 0, 0, c equals 3. Final answer, st equals negative 1/9 sine of 3t plus 7/3 t plus 3. Wow, that was a lot of work. You got to undo two derivatives, find the c values along the way. So that's it.